Hey, my name is Jonathan Helm, and in this video, I'll show you how to center predictors when running a multiple regression in R. So this video is going to build off of the last one, so I'm just going to continue on, and I'm still going to use the salary-data.csv dataset. So I've already read that into R, and I have it ready to go. If you want to review how to read this into R, just go back and rewatch some of the earlier videos in this playlist. So if I take a look at the top of my dataset, you'll see that I've actually already created number of pub C, which is a centered version of the number of publications. But actually, let me go through those steps again. So I'm just going to start from up here. I'm going to read in the same data set. I'm going to create a centered version of the predictor. All right, so what I want to be able to do first is actually create a mean-centered version. So in one of the previous videos, I predicted salary from number of publications. But number of publications was in a raw form, which meant that the intercept of that regression reflected someone who had a 0 average number of publications per year. And what I might want instead is someone who has an average number of publications per year. So what I need to be able to do is create a mean-centered version of this, right? So what I can do is I can say data $ number of pubs, and what I do is I just write _c for centered. All right, so I'm creating a new variable in the data set, and I say that's equal to data $ number of pubs minus mean of data $ number of pubs. Of course, I have to add in na.rm is equal to true. Okay, so what is this line of code doing? Well, this part of the code is saying calculate the mean, right, for the variable number of publications in the data set called data, right? So it's just calculating the mean. And of course, if it runs into any missing values, to remove those first and then calculate the mean after that. Then if I take that and I add in this whole line of code, this whole part of the code, it's saying extract out the variable called number of pubs from the data set called data, that's this part, and then subtract off the mean that you had just calculated, right? So calculate the mean first and then subtract it off from the actual values from number of publications. So that's going to create a new variable, and for that new variable, I want you to store it, right? This whole thing is going to create a new variable and then store it in the object number of publications _c, which is a new variable in the data set called data. Okay, so it's just creating a mean-centered version of that variable. Right, so if I highlight and run this, I'm not going to get any errors back, and if I look at the head of data again, I end up with this new variable called number of publications C. Right, so this is the original data set without it, and then after I ran that one line of code, it created that new variable, and now I see it here in R. Now, just taking a quick peek here, I'm going to run this part of the code. Right, this is actually just calculating that mean, and we see that the mean for number of publications is about 3.5. So if I'm looking down the rows of the data set, I can see that for this first individual, the original number of publications is about 4.0. So if I subtract off 3.5, I should end up with about 0.5. For the second individual, it's about 2.4. So if I subtract off the 3.5, I should end up with about -1, right? So it's really just that same variable, but now it has a mean-centered version. Okay, so the benefit of doing this is now I can run the linear regression using that mean-centered version. So I'm just going to scroll up to one of the original examples I used in one of the other videos and drop down here. I'm going to call this model 3. And I'm going to now predict salary from number of pubs _c. And I'm going to use the data set called data, right? Okay, so now that I do that, I can highlight and I can run this code. And I don't get any errors back, right? So if I look at the console, I ran the code and don't get any errors back. And so then I can look at the summary of that model. Right, and it estimates an intercept and a slope for me. Now the intercept is going to reflect, again, it's always the predicted value of the outcome when all of the predictors are 0. But number of pubs C, that's going to equal 0 for an individual who has average number of publications per year, in this case about 3.5. Right? So for an individual who has average number of publications per year, we expect them to make about $75,000 a year. Okay, and then for every 1 unit increase of publications, we expect that the salary will increase by about $5,600. Okay, so the benefit of using these mean-centered versions is that I get more maybe a clear interpretation of my intercept. Now, of course, whenever you're working with these, you don't have to center at the mean. This is kind of a convention in psychology. Most of us use mean centering. It also helps for interpreting interactions, which I'll get into in a later video. But you can also center at any location that you want. So let's say, for example, that I want to center at an individual who publishes on average once a year. Right? So in that situation, I'm not going to remove the mean. I'm just going to remove the value 1. So what I'm doing is I'm moving the 0 location of this variable to be for a person who publishes on average one paper per year. And I'm also going to change the label here so it's just something different, right? So not the centered version, but one that's centered at 1. So I'm just going to call this number of pubs underscore 1. Okay, so I'll highlight and I'll run this code. I'm going to take a look at the data set again. Okay, so I'm just going to make this a little bit wider. Hopefully we can see all the variables side by side, right? And you see that I get a new variable called number of pubs 1. And again, I just subtracted 1, so we can see that for this first individual, their number of publications minus 1 is 3. This person should be 1.41, which we see here. Right, 2.8 goes to 1.8, and so on. Okay. So if I go back now, I can use that variable instead. I'll call this model 4. I'm going to insert number of pubs 1. I'll call this model 4. So if I highlight and run this one, right, I don't get any errors back. If I highlight and run this part, you can see that I'm getting a different intercept, right? So this intercept reflects the expected salary for a faculty member who publishes on average 1 paper a year. Okay, 1 paper a year. And again, the rate of change is the same, right? So the slope isn't going to differ across these different analyses. It's just the value of our intercept. Okay. So this is how you can create those mean-centered variables. It's a fairly straightforward process. You can just start with the variable that you want to mean center and then perform whatever computation you want. You can subtract off the mean. You can subtract off a specific value to make the intercept reflect a specific point along the continuum for that variable. And then you just run the regression analysis the same way that you would as if you were using the raw variables. Thanks so much for watching the video. If you liked it, please press like. If you have any comments or questions, feel free to add those to the comments below, or you can email me directly at jonathanleehelm@gmail.com. Feel free to also follow me on Twitter. I hope this video was super helpful, and I hope the series is also helpful, and I look forward to hearing any feedback that you have. Thank you so much for watching.